this is an example of a multi-step angle of elevation depression problem. We're going to draw a picture and solve for a missing measure. Because we are working with trig functions, we are always going to think about that SOHCAHTOA, and we're also not going to round mid-problem. We're going to try to carry that value all the way through. Annabelle and Rich are setting up decorations for their school dance. Rich is standing 5 feet directly in front of Annabelle, under a disco ball. If the angle of elevation from Annabelle to the ball is 40 degrees, and Rich to the ball is 50 degrees, how high is the disco ball? So we are looking for the height of a disco ball. And we know we're working with a right triangle. So let's draw that right triangle. So there's two people in this picture. There is Annabelle, and 5 feet directly in front of her is Rich. So this 5 feet is only the distance between Annabelle and Rich. The angle of elevation for Annabelle is 40 degrees, and the angle of elevation for Rich is 50 degrees. So we have to find H. So since we already have this 5 feet, let's call this distance right here y. So y is going to be the distance between Rich and the disco ball. So this entire distance is going to be 5 plus y. And if we have to solve for h, let's think about which trig function we're going to use. So we know we have SOHCAHTOA. H is, with respect to the two angles, the opposite. So this right here is the opposite side. And then the 5y plus the 5 plus y, with respect to the 40 and 50, is the adjacent. So if we're dealing with the opposite and the adjacent, that's going to be the tangent function. So we're going to set up two formulas, or two equations right now. One for Rich, and one for Annabelle. So for Rich, we're going to use tangent, and his angle is 50. And H is his opposite, and Y is his adjacent. For Annabelle, we're going to do the same thing, but Annabelle's angle is 40. Her opposite is still H, but the adjacent is that entire length. So it has to be this whole length right here, which is 5 plus y. So if we look at this, let me think a little bit. There are two variables in this problem, an h and a y. And if we think about this, that h is in a position that it would be easy to solve both of these expressions, or both of these equations, for h. So if we solve Rich's for h, that's going to be y times tangent of 50 is equal to h. And I hope from all of our other problems you're able to see why we can solve for h that way. And if we think about the same thing for Annabelle, and we solve for h, we can do 5 plus y times tangent of 50 is equal to h. So now we have two expressions that are equal to h. And if they're both equal to h, just like from other math classes, when we were thinking about equal to y with substitution, we can set them equal to each other. So if we set these equal to each other, we have from Rich y times tangent of 50. And we have to remember that tangent of 50, they can't be separated. 50 has to stay with tangent, and tangent has to stay with 50. And then on the other side, we have 5 plus y times tangent of 40, because that is Annabelle's. So now we have something that's equal to each other, and now we only have one variable. So I'm going to move to the next slide so that we can work with this problem a little bit more. So we have this equation that Rich on one side, the y tangent of 50, is equal to Annabelle on the other side, 5 plus y times the tangent of 40. Now that tangent of 50 and that tangent of 40 are just numbers. So don't let the trig mess you up and make it seem different, but it's just a number. So if we think about having to solve for y, we can think about using distributive property on this side. And we can distribute that tangent of 40. And we have 5 times the tangent of 40 plus y times the tangent of 40. And I'm just keeping that tangent of 40 in a box because that 40 and that tangent cannot be separated. Just like on the other side, the y and the tangent of 50. Okay, the tangent of 50 cannot be separated from each other. It has to be tangent and 50. 50 can't go anywhere without that tangent, and the tangent can't go anywhere without that 50. So now if we think about combining like terms, if we were solving this equation and we didn't have any trig functions, we would want to combine like terms. And our like terms in this case are going to be the y. So we could subtract y tangent of 40 from this side. That crosses this out. Whatever we do to one side, we have to do to the other. And if we think about combining like terms, those y's don't cross each other out. We're just combining them together. So just like if it was 6y and 7y. So now we have y times the tangent of 50 minus y times the tangent of 40 is equal to 5 times the tangent of 40. And if we think again about wanting to solve for y, that variable, we have a like term in both of these problems. So we would like to factor that out. So we could factor out a y, and on the inside we're left with tangent of 50 minus tangent of 40. Now remember, that tangent and that 50 cannot be separated, and that tangent and that 40 can't be separated. So this is not tangent of 10, because I can't take away, I can't release those. They have to stay together. So from here, if we want to solve for y, right here we have multiplication. And if we think about how we get rid of multiplication, we do that with division. So we want y to be all by itself. So we can divide by what's being multiplied by y, which is tangent of 50 minus tangent of 40. That crosses each other out on one side. Whatever I do to one side, I have to do to the other. So on the other side, I'm also going to divide by the tangent of 50 minus the tangent of 40. So I have y is equal to 5 times the tangent of 40, all divided by the tangent of 50 minus the tangent of 40. But we're not quite done because we didn't want to solve for y. We wanted to solve for h. So if we think back to information from the first slide, we have this to solve for h because we want that value. And now we have y, so we can take this value of y that we just calculated and we can plug it in. So, if we want the value of h, we have 5 times the tangent of 40, all divided by the tangent of 50 minus the tangent of 40, times the tangent of 50 from this equation right here, and that's going to be equal to h. So from here you can pause the video and plug that into your calculator. So plugging that all into your calculator and using that calculator as the tool that it is, making sure that you have some parentheses. So the way that most calculators are going to have it is that I would do a large set of parentheses on top. But remember that when you put this into, a lot of those calculators have this original that puts in that parenthesis for you, so you're going to have to close it. Then the division sign, a large set of parentheses, and again, those smaller parentheses. A lot of calculators actually put these parentheses around the degrees for you. If yours doesn't, you don't have to do that. But you do need to have these large ones. Then you could hit enter at this point, or you could just hit times. And you can do tangent of 50. And just in case your calculator has that. So hopefully you've been practicing as we've been putting these in class together to see if you can get these same values. And the answer that you get here for h should be about 14.178 if we round appropriately. I believe in the units were feet. And that is the height of the disco ball.